Hello, and welcome to the second lesson of the Python Fundamentals curriculum. In this video, we are going to be covering everything from variables to a brief introduction of control statements. So, let's get started. To begin, variables are essentially labeled containers that store data values. During the execution of a program, the data can be accessed and manipulated, and we can use them for things like calculations and storing user input. To declare a variable in Python, we set the variable name equal to whatever data we want stored inside the variable. Here we have two examples of variables which are name and age, and they hold the data John and 17 respectively. When choosing a name for a variable, we do have to be mindful of some rules in Python. To summarize these rules basically, they can only contain letters, numbers, and underscores, but they can't start with a number. Also, we can't use reserved keywords like if, while, or for. And another thing to be mindful of is that variables are case sensitive. So here are some examples of legal and illegal variable names. First, let's look at the legal names. As you can see, all of them contain only alphanumeric characters and underscores, and also don't start with any numbers. Notice in our second legal example, max health, that when we want to use multiple words in a name, we use an underscore to separate the words instead of a space. Now let's look at the illegal names. The first example, second player, is illegal because the variable name starts with a number. Our second example, max health, is illegal because it contains a space. And finally, the last example is illegal because it's a reserved keyword in Python. The basic data types, also known as the primitive data types, are int, float, boolean, and string. Integers are whole numbers without decimal points. They can be positive or negative, and we use them for things like counting and indexing. Floats are positive or negative numbers with decimal points, and we use them for calculations involving fractional values. Booleans have two possible values only, which are true or false. We use them to represent logical values and control the flow of the program by making decisions. Strings are essentially sequences of characters that are enclosed in single or double quotes. We use them for storing and manipulating text. So, there is a way to specify or convert the type of variable, and this process is called typecasting. We do this by using Python's built-in functions, which include int, string, float, and even bool. Typecasting is useful when we have to convert a variable's data type to another in order to do some operation. We do have to be careful doing this though, since not all types can be converted to others. In these examples, we're basically using typecasting to convert the data type of the values inside the brackets of the functions to other data types. So, as you can see, for the value of x, we are putting 4 as a string to be converted to an integer. So the value of x actually ends up being 4 as an integer. For y, we are putting 5.5, which is a float, to be converted into an integer. This conversion actually gets rid of the decimal completely, so y ends up being 5 as an integer. For z, we're turning an integer into a float, so we're giving the value a decimal point, and for w, we are turning the integer into a string. In order to get the type of a variable, we can use the type function. So as you can see, when we use the type function on x and y and print the result, the output is the data type of the variables. Next, we have arithmetic operators, which are pretty self-explanatory. We just use them to perform mathematical operations, and they are on the screen for your reference. Some arithmetic operators that you might have never seen before are modulus and floor division. Modulus calculates the remainder when one number is divided by another, and floor division gives you the quotient without any decimal places. So it's a quotient rounded down to the nearest integer. Then we have assignment operators, which are used to assign or update values to variables. The only one that you really need to know is the equal sign, and the rest of them are just arithmetic operators combined with the equal sign. The reason we use them is to improve the conciseness and efficiency of the code, but they aren't completely necessary. Your code will still work fine if you assign values the standard way. The next important function is the input function, which actually allows us to take input from the user while the program is running. Let's see an example in detail. This is a simple program that takes a user's height in centimeters and converts it to inches. So let's run it. I'm going to enter my height in centimeters, and as you can see, it prints my height converted to inches. Notice how I used typecasting when I calculated the height in inches. I did this because the input function actually takes the user's input as a string instead of a float or an integer. So, we have to convert it from a string to a float first in order to perform the calculation, because otherwise it causes an error. This is the first practice question. Can you answer the output of this program? Pause the video and try to figure it out. Now we are going to move on to the basic things we can do with strings. Recall that strings are sequences of characters enclosed in quotation marks. The first thing is string concatenation, which is adding multiple strings together. As you can see in this example, string concatenation adds strings together without adding any white space in between. If you want to add a space, you can do so by adding a white space enclosed in quotation marks between A and B. Another thing we can do is use the upper and lower functions to change the case of the string. Upper makes the whole string uppercase, and lower makes the whole string lowercase. If we want to remove characters at the beginning and end of a string, we use the strip function. As you can see in this example, we are using the strip function to remove any ones at the beginning and end of the string, by specifying 1 as a parameter in the brackets. If we don't include any parameters in the brackets, the function removes white space by default. The length function is very simple. Generally speaking, it returns the number of items in an object, but for strings specifically, it returns the number of characters in the string, including white space. The last function for strings in this video is the replace function, which basically swaps one substring with another substring. So the 3 parameters we need to specify when using this function are the old substring, the new substring, and the number of times we want to replace the old substring within the original string. The last parameter is actually optional, and if you choose not to specify it, every instance of the old substring will be replaced. This is the second practice question. Feel free to pause the video and try it for yourself. Now we are moving on to comments, which are meant for guiding anyone reading your code, including yourself in the future. You can also use them to debug by temporarily disabling parts of your code, since the interpreter won't run any code that is commented out. For single-line comments, we use the hash or number symbol. For multi-line comments, we use either 2 sets of 3 quotation marks, which wrap around the multi-line comment, or multiple single-line comments. Both ways work fine. The in keyword has 2 main uses. The first one uses if statements to check if a value is present in some sequence, which we will see in the example after this one. The second use involves using a for loop to iterate through a sequence. As you can see in this example, we are using the in keyword to loop through the text and print every letter. If statements and for loops will be covered extensively in lesson 4, so don't worry if you're a bit lost. The last concept we will cover is a brief introduction to if statements. In Python, this is the structure for if statements. You have a condition, and if this condition evaluates to true, then the code that is indented after the colon will run. If the condition is not true, then the code indented after the else colon will run. In Python, indentation is very important, so make sure that you indent properly so that your code works as expected. So let's look at this example. We have a text, hello world, and we're using the in keyword to see if the string hello is contained in the text. Since hello is in the string hello world, the condition evaluates to true, and print said hello is run instead of print did not say hello. If the condition evaluated to false instead, like if we said something like if goodbye in text, then did not say hello would print instead, since hello world does not contain goodbye. This is the third and final practice question. Pause the video and try to write this program on your own. If you have questions about any of the content in the video, please feel free to message the Python Q&A channel on the Discord. Thanks for watching!